So we declare the license, Solidity compiler version, and do the necessary imports. After this, we have three addresses for each one of them. Alice, Bob, and Eve. These are public and immutable. Public because we don't want to hide their addresses. We only want to hide their wealth. And immutable, so these cannot be changed later on in the contract. Okay. Now we have these two mapping. First one maps their address to their wealth, and this is encrypted. And second one is to just keep a track of who has submitted and who hasn't submitted yet. Okay. This mapping is used in this submit wealth function, in which we first make sure that it is one of these three only and not anyone else. And we convert this encrypted values, which is encrypted bytes, into this data type. And yeah, we map them here. Okay, so this is the submit wealth function. Second one is the compare function, which is uh, comparing the wealth of these three. Okay, so we first create this encrypted indices for each participant. So Alex is 0, Bob is 1, Eve is 2. Then we have these two, best wealth and best ID. The best wealth is the wealth of the person who is the wealthiest among all three, and the best ID is the ID of the person who is the wealthiest. Okay, these encrypted IDs that we've created. Okay, now we start with assuming that Eve is the richest. So we will declare that wealth of Eve is the best, and the ID of the person who is the wealthiest is Eve. This assumption we begin with. After this, we compare the best person with Bob. So we compare Eve and Bob. Compare the wealth of Bob with the best wealth, which is Eve's wealth. GE is like greater than function, and then if and then yeah, we just update the best wealth and best ID according to whether Bob is richer than Eve or not. Okay, select is like if else statement, but for Inco. This is the first round of comparison. This is second round of comparison as well. Okay, in which we compare the winner of the previous round, could be Eve, could be Bob, with Alice, and the way of comparison is similar. Okay, we compare the wealth of Alice to that of the best wealth, and yeah. Now at the end we have this best ID, which is the ID of the person who is the wealthiest, and we only allow this thing to be revealed. We don't allow their wealth to be revealed. Nothing else. We only allow the ID of the person who is the wealthiest in the public. Okay. We request decryption of only this ID, and after this, yeah, we have this callback function to change this to determine the address of the richest person. With this decrypted ID, we get the address of the richest person, and then we send it to the front end. So this richest we emitted. So actually, I can show you. It is in wealth comparison. Yeah. So yeah, this one wait for the next event, and it just captures the one with the most wealth. Now we have some tests as well for this. I've written 4 tests. I'll show you. Yeah. So the first test is to find if someone unauthorized is trying to enter the wealth. Second, third, and fourth tests are for each one of the winners. So in one test, Alice will win. In one test, Bob will win. In another test, Eve will win. Okay, so first we test the unauthorized participant. In second one, we test if Alice is the richest. We give Alice the most wealth. And like similarly, we test if Bob is the richest. We give Bob the most wealth. And then we test if Eve is the richest. So I can run these tests and show you. Uh, Okay, so we see in the contract and code test. Yeah, so this works. And after this, I can run the app and show that as well. So I've written a script to automate all this. It restarts the Docker container first thing. Second, it deploys smart contract for us and updates the frontend with that. Now, after this, it runs the front end as well. Okay, so everything is automated this with this one script. Done. So we start with so we signed in as Alice. We have created these three test accounts to test it. Let's start as Bob. So that is let's say Bob has 1,000. Okay, yeah, Bob is done. Now after this, let's switch accounts to Alice. So let's say Alice has 10. And let's say Eve. Let's say Eve is one because after all of them had submitted, we can compare this levels. Okay. So the wealthiest is Bob with 1,000 rupees and we can accept it. Okay, so I almost forgot to show this. Just another end-to-end test that I've written using the Inco JS SDK. This simulates the entire process from deploying a smart contract to deploying a person with the most wealth. How it works is we give them the private keys and the wealth that each one of them have. And after this, it will connect to the local node, load all those values from the ENV, and then it will create those submissions on behalf of these three, and it will compare them, and in the end, it will admit the richest person. Okay, so yeah, I'll just show you. I'll just run and show you. So this one test, yeah, so this test that I've written. Another one was actually let me show the front end too. So in the front end, we test speed generate with WAGMI, and then to connect them, we have this Inco.js library that we're using. It connects to the local nodes that we're running, and then this is input value function which takes in the values entered by the user and it converts the plain text values into ciphertext that we can use later on. Okay, is another different value that's the opposite of that. Which is how the content is connected to the smart contract. Yeah, and this is where we have to update the address of the deployed smart contract, which happens automatically because of our the script that we have written. Okay, so this was the entire overview